In this demo, I will show you how you can analyse screening data which is based on Reference Singleton Spectra, i.e. where for each compound in your library you have a separate reference spectrum. Obviously for your control, target and possibly also displacer spectra, you will be using mixtures or cocktails of compounds. We're going to be using dataset 2 from our tutorial dataset to do this demo. This is simulated 19F data, which to be honest is probably not particularly realistic, but it will give you a nice idea of how the software works. So within the dataset 2 folder, there's this data folder which has all the spectra in it, and it also has this Excel file. It looks something like this. It's got a number of different sheets with lots of different information in it. We've got some additional documentation which takes you through how to create one of these files, what's required, what's optional, etc. So simply find your Excel file, drag it into your program. And this will not just open all the spectra that we need, it will also group the spectra into spectrum groups. It will also import information about your substances, and it will link the substances to the reference spectra. So you can see here we've got lots of different spectra. These are in fact the reference spectra. Let's just open one of them. You can see it's just a single peak here. That's because for 19F data typically you only have one peak per compound. If we go further down, then we can see we've got here our control data. So here we've got lots of peaks, so because that was recorded on a mixture of compounds. Then for the target, obviously the protein has been added, and for the displacer, then you additionally might add a displacer compound. So let's close this up. You can see here we've also grouped all of these spectra, references, control, target and displacer spectra, and you can see here we've also got all of the substances have been imported. If we double click on one of these, you can see under advanced that there is this link back here to the spectrum, which is the reference for that particular compound. Now what we want to start off with is to peak pick our spectra. We're going to start off by peak picking our reference spectra, and we're going to do that with a screening pipeline. So if you go to the screen menu and then screening pipeline, or you can use shortcut PI, and that will open this module here. Let's give ourselves some more space. And you can see here in the top left hand corner is where our input data goes. So we're just going to drag in our spectrum group, our references spectrum group. And so anything we now do on this pipeline will be done on all of the reference spectra. We're going to start off with this peak picking thresholds pipe. So I've just double clicked on that and it automatically appears here where we're going to build up our pipeline of actions that we do on our reference spectra. So you can set the threshold automatically. We're going to have a look here at how we can do it manually. So here's our spectrum, and if for instance you then click on this little toggle button with the target symbol, then we get this line which you can open up into an area, and you can set this as your area that will be excluded from peak picking. Or obviously you can also just enter these values manually over here if you prefer. Then we'll switch that one off again. Then next we need the peak picker, obviously for 1D spectra. So I can just double click on that and it'll be added here to our pipeline. No options for this one. And then finally we want to go to annotate peaks and add that. And so what that will do is once we've picked all our peaks, it will annotate them with the substance name or the substance that obviously linked to that particular reference spectrum. It's at this point perhaps worth pointing out that when you're doing screening, it's really helpful to have your preferences set to viewing annotations. So what I mean with that is if you go to File and Preferences and then the Peaks tab, you can see here for peak symbols we've got a number of different options for for our default labeling system. So if you're working with proteins, you'd probably want one of these options at the start, which bases your peak labeling on NMR atoms. But for the screening, we want to use just the annotation, which is basically just a single free text field. So make sure this is selected. So that's your default way of seeing your peak labels. Okay, so that's all done. So we can now run this pipeline. So simply click on the play button. And then here it's quite helpful to have a look at what's going on in your shell. We can see here the progress is being logged and we're done. So you can see that took 25 seconds. Obviously, the length of time will depend on what else you're doing on your computer and how large your library is. Okay, the next step then will be to peak pick our other spectra. Perhaps first let's just have a look. Here you can see this has been peak picked and has indeed been annotated with the compound. Okay, so let's just right click here and we can close all of these. And now what we want to do is peak pick all the other spectra as well. Now we're not going to peak pick those from scratch as we did with the reference spectra. Instead we're going to copy the peaks over because we find that that is a much better way to then automatically match peaks together, group them together as belonging or arising from the same compound. If you peak pick each spectrum from scratch, you can end up with different numbers of peaks picked in each spectrum, and then it becomes very difficult to start automatically matching up which peaks are equivalent in the different samples. So we're going to start off once again with our peak picking thresholds. This time we'll just do auto. This essentially bases it on sort of noise levels at the edge of the spectrum. Then we, as our next type, will want to use propagate peaks from references. So what this does is, obviously in our control spectrum we've got peaks from lots of compounds, so it'll copy from lots of different reference spectra all into the same control spectrum. And so we just need to set this to control, and then we're all set. The next pipe we want to use is this copy peak lists, and this will now use in order to copy things from the control spectra over to the target and displacer spectra. So our origin spectrum group therefore is the control group. We don't need to copy them over to the control spectrum group because we already have those, but we do want to copy them to the target and the displacer. Here it's perhaps worth noting if you were using reference mixtures rather than reference singleton spectra, you would here at this point copy from the references and then to control, target and displacer. Everything else we can leave as it is, and then finally we just want to go to set up screening dataset. So this will then collate all of your peaks and data into a new data table. You can give this a new name if you like. Our origin spectrum group in this case is the control spectrum group. Everything else we can leave. Obviously if you were using protons you would need to change this. The matching engine, we're going to use the annotation match, which will basically group everything by the annotation. So that's how we'll know that the peaks and the different in the control, the target and the displacer are all referring to the same compound. But you can also use these other algorithms, nearest match, DTW is dynamic time warping, or k-means. So do experiment with that by all means. It does depend a little bit on the quality of your spectra and how much the peaks have moved between the references and the controls and then the other spectra that you have. So that's all we need to do, and now we can run our pipeline. So again we'll click on play, and down below in our terminal window we can again have a look at some of the progress. So you can see this all completed very quickly. It depends a little bit on what else you're doing on your computer, how big your library is, and that kind of thing as to how long it will take. But hopefully it shouldn't take more than, even for 5,000 compounds in your library, it shouldn't take more than 5 minutes at most. So you can see all of these peaks have been nicely picked and annotated. And so now we're ready to analyse some of our data. So we're going to get rid of this pipeline module and instead, from the screening menu, open the hit analysis module. So what that final pipe did was give us a new data table with all information on our screening set, and that's basically what we're going to select here in this little drop down. And you will then see that in this hit analysis module we've got 3 main areas. So we've got this table up here on the left hand side, we've got a table down here, and a flexible graphing area. At the top you can see that we've got 3 different view modes. So at the moment we're looking at this by samples. So you can see here are 10 samples in total, and if we click on these, then the data in the graph will update, and so will this table down here. So this table down here will now show all the peaks that are in that particular sample. And if we click into here and then use our arrow keys on the keyboard, we can move through these, and you can see that the spectrum display updates and moves to that particular peak each time. Now we can also view things by substances. So in that case we've got all of our substances will be listed here, and again when you click on one of these substances, then the lower table will show all the peaks that are part of that substance. Obviously, because with this 19F data we've got a single peak here. If you were looking at 1H data, then you'd probably have multiple peaks. Finally, you have this option to look at matches only. That's essentially looking at per peak, or I suppose peak group, given that your 1H spectrum, your 1H peaks might also be split into multiplets. And again, you can then just move through these and inspect your data manually very easily if you would like to. Finally, let's have a look at this plotting area. You can select what it is you want to plot on each axis. So here we've got our binding score, which we can plot, for instance, against our displacement score, and might expect some of these compounds up here to be some of our best hits. You can see if I click on something in the graph, then the tables will update, as will the spectrum display. And finally here on this little edit panel, you can select to flag things. We've got a number of different options here. If I select that to be a hit, then it will colour it green in the graph and have that as its peak label here in that column. Finally, I want to draw your attention to what's in the settings menu. So here you've got a number of different options. You can select the way in which you're calculating, for instance, your binding score. Obviously, particularly if you're using STD or autology spectra, you'll need to use different equations. This total score is the total score per sample. You may decide you'd like to use the maximum rather than the sum. That then just gets updated in real time. This is to do with the matching score. Again, you could set that for the total score. We can change that. The appearance lets you change the way in which this zooming on the spectrum display works, or how easily the table is updated as soon as you make any changes. And these are all to do with the graphing area. Finally, we've got lots of filtering options. So This refers to the match view, substances view, or samples view, and you can set a wide variety of different filters, and then if you want to apply those, you simply click on this filter button here. In addition, of course, you can also sort any of your columns by just clicking on the column header, and by right-clicking, go to column settings. You can select which columns you want to view. By right-clicking and going to filter, then you also have a number of additional filtering options. So all of those sort of standard ways of dealing with tables in the program remain as always. And finally, we're in the process of adding in another option, which is if in the substance view, if you select a number of substances, then you can right-click and create report for selected substances, and that will basically create a PowerPoint file with a report for those substances, giving you a little picture of your spectrum and some of the scores associated with that substance. If you have smiles in the program, then it will also give you a little structure of that compound. We hope that's given you a nice little bit of an overview of the way in which the screening program works. We're now in the process of updating some of our documentation, and you'll be able to have a look at specific elements there. And obviously there are also other ways of doing this if you want to do things rather more manually rather than using the pipelines, or if you want to use reference mixtures, which is something which we advocate, particularly in situations where you find that your peaks will move quite a lot between different screens or between your references and your controls. We're always happy to meet up with people and provide additional support and advice to anyone who's setting out on a screening project and wants a bit of help in getting set up, particularly first time round. Setting up your Excel file can be quite hard work, and we can easily help you with some scripts to get all of that going first time round. So do be in touch.